Hello Hopewell, this is Mr. Steinberg. Today's lesson, we're going to continue with our exploration on our conic sections. Today's conic section is a circle. Imagine we have a cone that looks something like this. The base of this cone is a circle. Imagine intersecting this cone with a plane that runs parallel to this base. That intersection of that plane and this cone will form a circle, a perfectly round circle. The definition for a circle is up here. It's a set of points that are the same distance away from a central point, a point that's not contained on the circle but in the middle of that circle. The distance from the center to any point on the circle is always the same and that length is called your radius. Next we have the formula. This is our standard form equation for a circle, and it looks very familiar to us. We know that x squared plus y squared equals the radius squared. And why do we know this? Think back to chapter 9. Any point on this coordinate plane has an x and a y coordinate pair. Any point on this plane has a horizontal and a vertical distance that can make a right triangle for it. So this basically is a restatement of your Pythagorean theorem, where the length of one leg squared added to the length of the other leg squared equals the length of your hypotenuse, in this case your radius squared. So this is a Pythagorean theorem formula for any point that's located on the boundary of the circle. Okay, now what if the center of the circle does not appear at 0, 0 as this one does? Let's say we move the center of the circle h units horizontally and k units vertically. Then we will create a new formula for our circles. X minus h squared plus the quantity y minus k squared equals your radius squared. This still has a radius of r units and has a center at hk. So when I get to the bottom, there's two exercises. It says determine the characteristics of a circle with the following equation. Analyze this first equation. Next to the x, I don't see any sort of constant that's being squared. Same thing with the y. This indicates that the center of the circle is in fact our origin, the point 0, 0. The 9 represents the square of the radius. So if r squared equals 9, then r could equal positive or negative 3. However, that being said, a radius is a length. Length should never be negative. So the radius will be 3 units long, and that's all the information we can get out of this formula. When I go down to question B, I notice that this formula does not look the same as anything that I've seen yet before. I do have an x squared with no constants next to it. I do have a y squared. Then I have these other terms, and I'm wondering why this looks so different than the rest. How can I be able to analyze this sort of equation that doesn't look like the standard form equations that I have up here? What I do notice is that when I look back at this equation, a rewritten circle equation with a center at hk, I'm noticing that I have binomial squares whose products will always be perfect square trinomials. When I look at the bottom, I have only one constant term. I have linear terms and quadratic terms for both the x and the y. What I think to do first is, why don't we complete a square to turn these two x terms into a perfect square trinomial, and these two y squared terms into a perfect square trinomial on the left. Whatever constants I add to the left side, I have to add the same value to the right side. So let's complete the square. In order to complete the square, we take the middle term, take its coefficient, divide it by 2 to make it 6, square it, and add that quantity to both sides. So I'll put a 36 on both sides. That completes the square for the x's. For the y's, take the middle coefficient, negative 8 divided by 2 makes negative 4, square it, and add it to both sides. Let's simplify this entire expression. I guess we'll start with the left-hand side. Because this is a perfect square trinomial, it can factor as a binomial squared. Since these three terms is also another perfect square trinomial, it will factor as a binomial squared. All I need to do is now simplify this right-hand side, and I'll have an equation that looks similar to a translated circle whose center is not 0, 0. Let's add the ones place. 6 and 6 is 12. 3 more than 12 is 15. Drop the 5, carry the 1. 30, 40, 50. With the 1 I carry would be 60. So this is the equation for the circle. What do I know about it? We know that the center of this circle, since I see a plus, would translate left 6. Since I see a minus, would be up 4. The center of this circle is negative 6, positive 4. What is the radius? The radius squared equals 65. So the radius is the primary square root, positive square root of 65. This, I'm going to try to simplify it, but the only thing I can think of is 13 and 5. Both of these are prime numbers, neither are perfect square, and I don't need to simplify it. The radius is the square root of 65 units long. Let's move on to our next video.